Hello everyone, this is Ali Reza. In this episode, we will create bunch of nodes in one go. As I said in previous video, they are really easy, so implementing them wouldn't take time. So let's add some namespaces, actions and conditions and anything else. Nope. So actions and conditions. Okay. In action, we will have some classes like BT action node. And was it this? No, it was this. Okay. Then we will have class BT counter node. We will have BT flop node. We will have BT timer node. And in conditions, we will have only one class, BT condition node, for time being, of course. Okay? And we will have their schemas, so BT action node schema, BT counter node schema, BT flop node schema, and BT timer node schema. Then in condition, we will have BT condition node schema. Okay, and those are all. So BT base node schema node, BT node schema node, BT node schema. And by the way, I just type node, one left arrow, and it will find the correct namespace. So BT base node schema node, BT base node schema node, and let's do the schemas first, because again the schemas are really easy. So BT node action schema is this. Basically, actions won't have any output. Also, condition won't have any output. And when it's being ticked, it will tick the delegate method. It will invoke the delegate method. So it will have a delegate method. And later on, we will implement few methods in the base graph that will let you pull out a node by its name or its ID, okay? So basically in your agents, you will get your ID, you will write down your ID basically from the editor. You will pull the node out by its ID, then you will assign the delegate to the action, and you'll tick your graph normally. So that's the action. BT counter. Now, BT counter will have two different things. So one is the initialize. That's the simple one. Okay. Counter will keep on running state on ticks, as many ticks as you define. So for example, if you set the counter to 10, then for 10 ticks, it will keep on running state. and then it will return success. Okay? So the other thing that we want to add, remember, until now, none of the nodes had a property. Well, counter has a property, timer has a property. Others, again, won't have a property. So now we want to draw its property. So override, where is that guy? Draw GUI, draw node properties, there we go. Okay. After calling the base, we say GUI layout dot space of 5 pixels. Then GUI layout dot begin horizontal. This is my habit. GUI layout dot end horizontal. Inside the horizontal, and by the way, after the horizontal, we'll say GUI layout dot space of 5, so that the metadata would show properly. In here, we say GUI layout dot label counter, and then we say we need to cast to BT counter node our related node dot counter. We don't have this property yet, but we will add it. Okay, equals to editor GUI layout dot int field of BT counter node related node and dot counter, and that's it. Okay, so the counter, I will add it, and then this error will be gone. BT flip-flop is just again having its initialize with the help and icon. And remember, we clear the output of BT flip-flop, counter, timer, condition. None of them will have an output. Okay, these are sort of action nodes that I'm adding here, except the condition node is a condition node and it's really not having any output because it's again having a delegate. So then we have the timer that has its own initialize, and again the timer will override its draw node properties, and it's fairly close to counter, so I will copy it from here, putting it after the base, and yeah, import the namespaces, and we say timer BT timer node, and instead of counter we have timer BT timer node timer. Okay, and finally our condition schema. So that's that. Now, as I said, condition node will have a delegate that returns a boolean. So again, you will pull out this node by its ID from the graph, assign its delegate, run its delegate, and then if the delegate returns true, the node will return success. If the delegate returns false, the node will return false, and it will be in a try catch. So if it bugs anywhere, the node will return failure. No, not failure, error. Okay. So I will close this guy. I will close flip-flop, and I will just keep the counter and the timer so that we see that these errors will be gone. And we will start with BT action node, the easiest one. So BT action node is again BT base node, and it's a node. So we override two methods, initialize tick. We don't have a reset here. So in initialize after base, we just clear our outputs. In tick, we say if, and by the way, I forgot something. Here in action node, as I said, we will have a delegate public func that returns evaluation state, and we call it action. Here we say if action equals null, we say our state equals to errored. An action without anything means it doesn't need to be here, so why to keep it there? We errored so that in the editor the guy can, the operator can see it and say, okay, oh, I forgot this gun. Then we say state equals to action invoke. That's it, and we return the base. That's our action node. Believe it, that's our action node. Then we will go with the counter. The counter is again BT base node. Come on. Okay, now we have a serialized field public int counter, and just by doing that, this guy should be fixed. There we go. It's fixed. Okay. And after that, we have another serialized field, but this one is private, int count. Okay. And we override our reset, our tick, and our initialize. So, or not, what did I do? P properties? You're kidding me. Wow, this is, I never noticed that. Okay, override, initialize, tick, and reset. In initialize, we clear our outputs, dot clear. Then we say our count equals to counter, but we add 1 to it. Okay, why did I add 1 here? Because it makes sense, you know, you set 10 in the editor and you say, okay, it will keep running for 10 ticks. And you will see right now that at the start of the tick, I will say count minus minus. So if you set 10 and you just set the counter equals to counter, count equals to counter, then for 9 ticks it would keep running. The 10th one, it would return success. Now we say if count less than or equal to 0, we say our state equals to, of course, success. And parent graph dot active node equals to inputs at 0 dot connection node at 0. So we set our parent as active node. Else, we set our state to be running. Now, in reset, after calling the base, all we need to do is to say our count equals counter plus 1. And that's it. Our counter node is done. Then flip-flop. Flip-flop is BT base node. Get used to this guy, node. Okay. Now, flip-flop will have a serialized field of private bool calling flipped. This node is a little bit different from the rest, meaning that Well, first of all, we have our overrides for initialize, tick, and reset. But after them, we will have a public void flip method. Now in flip method, all we do, we say flipped equals not flipped. Okay? In initialize, we say flipped equals to false. In reset, we say flipped equals false. In reset, in tick, sorry, we say state equals to flipped. If that is the case, evaluation state of success. Otherwise, evaluation state of running. So you again are responsible of flipping this method. Okay, so you have to pull this node out of the graph and then call its flip method the moment you want this node to return success. And that's it. Then timer. Timer is close to counter, but let's see. We have a serialized field, public float timer, and this should fix our error here. What's wrong with you? Oh, I forgot. I forgot a few things. BT base node and node. Now you should be fixed. Come on. Int field. There we go. This should be a float field. Okay? For the timer. So after this, we will have two serialized fields that will be private. So private float cooldown and serialized field private float date time. Ah, come on. No, not float. Private date time. Oof, if I can manage it. Well, don't blame me. It's 2 a.m. Last time. Why did I use date time? Date time has this really interesting ability to, you know, track the UTC now and then subtract stuff from itself. I originally was planning on using time.delta time, but then I noticed that when I'm ticking manually in the editor, time.delta time has no meaning. So I switched back to use the date time. So we have our overloads for initial and tick and reset. In initialize, we say outputs.clear. Then we say cooldown equals to the timer. Last time equals to, well, if I see UTC now, that's it. In tick method, I will say cooldown minus equal to cast to float our UTC now. Come on, you were behaving previously. Date time dot UTC now dot subtract, and you see that it accepts a date time. Well, we have the last time, but what we want is total seconds. We can use milliseconds. Well, we can use milliseconds, you know, but total seconds is returning a double, so it means it can be 0 point something. So total seconds. I will say if cooldown is less than or equals to 0, do stuff, else do stuff. And finally here we say last time equals UTC now. Okay? Here in if we say state equals to success and parent graph dot active node equals to inputs at 0 dot connection node at 0. Okay? If the cooldown is not set to 0, well, state equals to running. And finally, in reset, we reset our two params. So cooldown equals to timer and last time equals to UTC now. That's it. That's our timer node. Finally, our condition node. Condition node is a BT based node. It will have a public func that returns a boolean and we call it condition. Then we will add our overloads for initialize and tick. Here we say outputs.clear. In tick method we say if condition dot method equals null, then we do two things. We say our state equals to evaluation state of errored and we return base.ticked. No, not toString. Tick. And also I noticed something. In our action node, we are checking the action. We can say action dot method equals null. Now, after this, we say state equals to run the condition, but then if that will return true, we say evaluation of success. If returned false, well, evaluation failure. And that's our condition node. Okay? So, yeah, we are done. Let's build. Go back to Unity. Let's delete the whole graph, create a new graph, and let's add, oh, I forgot the menus. Okay, last bit of business, add these guys. So actions I will add here directly, and I will add it after the sequence before the others. So BT action. This is action, and then we have the counter, and those are in the actions. So we have action / counter BT counter. We have flip-flop. BT flip-flop. And finally we have timer here. BT timer. Then we have our condition. So, well, I will add the condition directly here because it's one of those nodes that if you know how to handle it, you really don't need anything else. So BT condition. I mean, if you remember from previous video, we had that compare values, we had can see, can hear, within range. Those are all conditions. I'm just making your life easier later down the road by just creating some nodes for you. Otherwise, right now, honestly, right now, you have almost a complete behavior tree solution. We only need 2 more nodes to make a very base, powerful behavior tree system. So let's build this guy. Come back to Unity. And let's create our action first, because I want to see if that error state would return. Yeah, that's working. Okay. So reset. And of course, the condition for time being, oh, I'm using it this for condition. Okay, it will return error because they are not having any delegates for themselves. Then we have our counter, and you'll see that we have this count. Let's put 3. So for 3 ticks, I should get running. Ready? 1, and I got success because I didn't reset it. So 1, 2, 3. The next one, return success. Okay? So that's our counter. I can't test flip-flop because, well, I can't flip it. But timer, I will put it for, I don't know, 15 seconds. I will reset, then start. 1001, 1002, 1003, 1004, 1005, 1006, 7, 8, 9, 10, 11, 12, 13. I counted a bit wrong, but it's really 15 seconds, okay? And that's our timer. And just so that you see its face, this is flip-flop. Of course, no matter how much I tick it right now, it will return running because I'm not flipping it manually. Well, let's see. I can sort of mimic this. I hope I can. So reset, tick, it will return running. But if I look at this guy, we have this flipped, okay? So I manually flip this guy and then tick, and it returns success. So the moment, no matter how much I'm ticking, I'm actually clicking my mouse like crazy, like a mad monkey. But the moment I flip it, the next tick, it will return success. That's our flip-flop. Action and condition, well, you need to code some delegates for that, but I tested the code and it's really straightforward. I mean, what's complex here? We set our state to the action, and the condition is really straightforward. So there's nothing complex here. This code will work. The only thing you may ask is that, hey, the condition node is not asking any parameters. The action node is not asking for any parameters. They are just returning values. So this guy would be like, you know, public evaluation state my action blah. I can assign this method to this delegate. What if I want parameters? Well, honestly, if you want to cover that, you would need to have, I don't know, 16 more actions. I mean, like this, you know, func of object as the first param, and then evaluation state action one param. This will get crazy, you know, until 16 params. Instead, if you get smart, you can have this public void. Actually, it needs to be evaluation state, I think. Evaluation state method, for example, with params. Then you would have, for example, int a, float b, I don't know, string c. Okay, and then you would handle those parameters here, and inside of this guy, actually no, what you would do, I think you would set some private fields here, maybe properties, maybe private fields. You will set them here, and inside your action you will read them and use them. So if you want parameters for a delegate that you will send into a node, remember that the delegate is just a pointer to that method on that object on that memory. So any private fields, any properties you have on that object in memory is acceptable for the object itself, so that non-parameterized method can use them, and the delegate will only go and say, hey, do your job. That's it. So maybe we will see that in future. I'm not sure, but the way I think you would handle that is to have some private fields or properties. You will have a public method somewhere that sets these guys, or you set them manually inside your code, and then when the assigned method to this delegate will be called, inside its body it will read those parameters. That's how you should do that. Anyway, in my notes, believe it or not, we are at the end of my R&D. This was the end of my R&D, so my R&D project is bye-bye. And I'm very happy because in my R&D I had some few bugs, especially on the sequence, that we don't have it anymore. And from here, let me do this here. We can use my R&D stuff as a roadmap. So I will copy from my R&D what we had. So the selector is done. The sequence is done. The parallel node, well, we need to address it in next episode. It's really simple. We will see. Reference, and I have to put that BT there. The reference is a special node that will accept any other behavior tree as parameter, and it will tick it and return the result of that. So BT action was done. BT condition is done. Random selector is done. Random sequence is done. BT counter is done. Flip what did I hit? Okay. Flip-flop is done. Now, remember I said these guys will be one node, and I will call it BT reflection. And this is not promised, so whatever. BT timer is done. These guys are conditions, so BT can hear. BT can see. And I will say compare value because it will be again both the property and the field. Random probability. Received event. Then we have within distance. And I will move this within distance up close to can hear and can see. The BT success is done. BT failure is done. Interrupt. And repeat. And finally, until failure and until success. If you think about it, now let's remove those that we had finished so that we get a to-do list. Okay, if you think about it, the can here can be a condition. Simply like that. Can see and within distance are conditions. Okay, compare value is another condition. Random probability is another condition. And then until failure and until success actually are no, they can't be fit with others. So received event is actually another condition, but the rest are not. Okay, so if you look, we could fit 6 nodes into the condition node that we have, just like that. So I can simply hit the delete key and say I'm done with these 6 nodes. But you know, I want to add these guys for ease of use for our system. In next episode, I will do the parallel, then I think I will do these guys. So this is the list of to-dos. The reference, I will do them at the end. Send event, I'm not sure. Receive event, I'm not sure. So remember, not promised. Sorry guys, I need to learn things first, then help you. And then we have random probability after them, then reflection, compared value, Well, I will do these guys there. So this is the list of to-dos. I hope you enjoyed the system up until now. And we will see you guys in the next video. Have fun, everyone. Bye bye.